Question 19. Which of these is a redox reaction, so it has reduction and oxidation? So you've got to look for the obvious answer. The obvious answer is D. So the obvious answer D has magnesium. Magnesium on its own in oxidation state 0 goes to MgS. Now in MgS you've got magnesium sulfide. So Mg has become 2+. As it's given 2 electrons away to the S. S is in group 6, so wants to gain 2 electrons. Mg is in group 2, so wants to lose 2 electrons. So the Mg will give 2 electrons to the S and form an ionic bond. Mg2 plus S2 minus. So the Mg has gone from 0 oxidation state, not bonded to anything, it's got no charge, 0 oxidation state to 2 plus 2 oxidation state. So that has gone from 0 up to +2, it's been oxidized. The S has gone from 0, just on its own, an element on its own with no charge, 0, to S2 minus, because it's in group 6 and gained 2 electrons, taking them from the Mg. 2 minus, gone from 0 down to -2, that's been reduced. So you've got oxidation and reduction, so that's the obvious answer, D. And so I'd ignore some of these more complicated equations here and look straight to D. 2.4 grams of an explosive J contains a certain number of grams of nitrogen, certain number of percentage of carbon, percentage of hydrogen, the remainder of J is oxygen. I need to get these into all into percentages, all into the same units. So I can work out the percentage of nitrogen in the 2.4 grams. I've got 0.473 grams out of the 2.4 grams. I've got 0.473 divided by 2.4 multiplied by 100%, it gives me the percentage of nitrogen in there. So now I've got percentages, the remainder is oxygen, so I can do 100, take away the 19.71 which is nitrogen, take away the 33.8 which is carbon, take away the 1.41 which is hydrogen. And it tells me that 45.08%, the remainder, is oxygen. I divide by the masses of each of the atoms to get the ratio of the amounts. So 19.41 divided by 14, and a mass of nitrogen is 14. 33.8 divided by 12, the mass of a carbon is 12. 1.41% divided by the mass of a hydrogen, which is 1. And 45.08% for the oxygen divided by the mass of an oxygen, which is 16. Gives me these ratios, 1.41 to 2.82 to 1.41 to 2.82. To get the simplest ratio, I divide by the smallest number. So I divide all of them by 1.41. It comes out as 1 to 2 to 1 to 2. So the number of nitrogens is 1, the number of carbons is 2, the number of hydrogens is 1, and the number of oxygens is 2. The answer is C, C2H1N1O2.